well. अच्छा, इसमें पहला क्वेश्चन ये कि they're asking you compare and explain the relative acidities of 2-chloropropanoic acid, 3-chloropropanoic acid and propanoic acid. तो इसका जल्दी से वो डिस्कस कर लेते हैं कि you have propanoic acid, it's got 3 carbon atoms और यहाँ पे double bond O और OH होता है. The OH breaks off, the H plus 1 is released. ठीक है, and it's going to have all of these are hydrogen atoms. ठीक है, so that's your propanoic acid. फिर वो कह रहे explanation भी देनी है साथ ही. Then you have let's go with 3-chloropropanoic acid. So it's propanoic acid and OH, the H plus 1 breaks off, and it's 3-chloro. So that means on the third one there's a Cl. And then you've got 2-chloropropanoic acid, which is going to be, you're going to have 3 carbon atoms, and there's going to be a double bond O, and OH, H breaks off, and 2-chloro means on the second one there's a Cl, and there are hydrogen atoms on the rest. Now all of them are carboxylic acids. We did learn how to figure out the acidity of carboxylic acid. How did you figure out? I told you if the negative charge on this is large, if this thing has a large negative charge, so it's going to be a weak acid because H plus 1 जो है ना वो वापस it would strongly be attracted back again. Right? Is this clear?
Yes, sir.
So everything depends on the negative charge, on this negative charge, whether this negative charge is large or small, or if it's large, then the H plus 1 will not dissociate, and it's going to be considered a weak acid. So what did I tell you about carbon chains? That carbon chains, whenever you have a carbon chain, it has an electron donating effect. So which is why the negative charge over here is going to have a large charge density. So that one is going to have a very large charge density, and this one is going to be the weakest acid out of the 3. Okay, because the alkyl chain over here is also pushing the electron density towards this oxygen, which is negatively charged. Is this clear?
Yes, sir.
So these two, how would you compare these two? In these two, you've got a Cl. Now a Cl has an electron withdrawing effect. So what this Cl would do is that negative charge यहाँ पे, so it would start to withdraw electrons. Okay, so the negative charge at this point is not going to be very large, and the H plus 1 would therefore not be attracted that strongly. So ये आपका so this one would be your stronger acid because the H plus 1 is not getting attracted back, so it would dissociate. The same is happening over here as well. You've got a negative charge and the H, so ये ना वापस all the electrons are getting pulled back again. So the negative charge is less. I say in both cases, the negative charge is less, but which one out of the two do you think is going to be the stronger acid? किसका negative charge ज़्यादा कम होगा? The last one or the middle one? Any idea, Lubena? Any idea? Ruba?
The last one would be the stronger acid.
Okay, the last one is going to be the stronger acid because Cl is closer to this CO minus 1 group. I mean, it's on the second carbon atom, so it's much closer. So the electron withdrawing effect is going to be larger. It's going to have a larger electron withdrawing effect. Is this clear? And over here, Cl is much. I said over here, Cl is much further away. It's on the last carbon atom. So uski jo power hogi na to pull the electrons away from this oxygen, that would diminish by a huge margin. It's not going to pull the electrons that effectively. So Cl is further away. and there's going to be relatively lesser electron withdrawing effect. So it's further away from the RCO -1 group. So it would have a less electron withdrawing effect. Anyways, so this is the least acidic, क्योंकि इसका negative charge बहुत ज़्यादा है, ठीक है? So it's the least acidic. And this one over here is the most acidic, ठीक है? I mean, you'll get probably 1 mark or 2 marks for this, and 1-2 marks for the explanation. In the explanation, you're only going to talk about alkyl chains having electron donating effect. Okay, so over here you're going to mention this, that it's going to have electron. You're going to talk about the electron donating effect of alkyl chain. Because of that, the ion becomes unstable. Is unstable. So use the word unstable. What that simply means is that the negative charge would be so large that it would immediately attract the H+1 back again because of the larger negative charge. So it's unstable. For these two, you're going to talk about Cl having an electron withdrawing effect, and you're going to talk about that this is closer, and this is further away. So over here, you get a more stable ion. Or you can talk about the charge density. The RCO -1 ion has a lesser charge density. So is this clear?
Yes, sir.
Achha, Skara, we can also, one second. So this is S20 QP42. I mean, that's the first part. We just did the first part. It's 20 QP42 because you get the same answer over and over again. It's a latest paper hai. So we should even have a look at the market scheme, okay, how the answer is phrased. ठीक है, latest के अंदर देख लेते हैं कि latest के अंदर they using the same terms or not. So this was question number 6 of this paper. But question number 6 is something. So I think this is S20 QP42. So maybe it's अच्छा, एक तो ये है strongest and that's the weakest, ठीक है? And तो stabilizes the anion, तो वो anion हमने quote कर दिया था, ठीक है? It becomes stable as they contain electronegative Cl, तो उसका withdrawing effect है, ठीक है? That pretty much means the same thing. और उसमें वो Cl is closer to that thing, तो the ion is more stable. अच्छा, पहले का उन्होंने नहीं मेंशन किया, उसके मार्क्स नहीं दिए alkyl chain के, ठीक है? They just had 3 marks, so they didn't award any marks for they didn't award any marks for the alkyl chain part, ठीक है? उसका कोई mark नहीं था. अच्छा, coming back to this, इसका जो part B है, the numerical value of Ka for methanoic acid and pyruvic acid is a given. Actually, it was this question is more about I mean, it's less about Ka. The question is, an equilibrium mixture containing 2 acid-base pairs is formed. Using the K values to calculate the equilibrium constant K equilibrium for this equilibrium. So the question is, I'm going to rephrase it. The question is, you're supposed to find the equilibrium constant for this thing. Okay, that's what they're looking for. So write down the expression that K equilibrium is products over reactants. So you've got your products and you've got your reactants. Your products are HC double OH concentration. Okay, that's one of your products, and the other one is this one. So it's CH3CO CO and CO2 minus 1. So you've got those are your two products, and your two reactants are, so you're going to divide that by your reactant, and your reactants are each CO2 minus 1 ion, and the other one is CH3 CO2H concentration. So products over reactants, and you have to somehow give the value of the equilibrium constant. So you have to somehow, and he's saying use the K values, use these K values. So what are you going to do? Now the thing is, this is a completely different reaction. It has nothing to do with the acid-base reaction that we studied. But he's saying, K, use the K values given over here and find the value of this. So you have to somehow link the K values of this with this expression. So what we're going to do is we're going to code the K values. For example, you've got HCO2H. So what is the dissociation constant? Dissociation constant is the equilibrium constant for the dissociation of this weak acid. So it would form HCO2 minus 1 and H plus 1 ion are going to be released. I'm going to call this K1. It's going to be product concentration over reactants concentration. So it's going to be HCO2 minus 1 concentration into H positive ion concentration. And you're going to divide the whole thing by the reactant concentration, which is HCO2H concentration. So that is one expression I've gotten for Ka1. Is this clear?
Yes.
Then you've got this other acid. It's similar. It's I'm going to write its dissociation. It's CH3CO and CO2H. So its dissociation is going to be that the H is going to be lost. So it's going to become CH3CO CO2 minus 1 and H plus 1 is going to be released. Now this reaction is, let's call this Ka2, products over reactants. So it's going to be CH3 CO CO2 minus 1 concentration times H plus 1 concentration. And the whole thing would be divided by the reactant concentration, which in this case is CH3CO CO2H. So you've gotten these two expressions, K1 and K2, and you have the values as well. They've quoted the values. So can anyone tell me how would you find the equilibrium constant which is given over here, this expression? Any idea? Like, how can you convert K1, whose value you already know this value, and this K2 dissociation constant 2, you know both values. How can you use their values and somehow use use their values and put them in the expression over here? Good idea? Lubena, any idea? Shafak, no idea.
Maybe we're going to use Ka1 over Ka2.
It's going to be K1 over K2. I think it's going to be K2 over K1. That's the first thing. What I'm going to do is I think it's going to be K2 over K1. First thing, I'm going to figure out the answer to this expression. It's HCO concentration. So you can see the expression is over here. If I rewrite this expression, it's going to be bring HCOH to the top, right? and divide it by HCO2 minus 1. So it's going to become H plus 1 concentration divided by K1. Is this clear? Right? So I've gotten the value of this thing because this thing was given over here. So I took the H plus 1 over there and took the reciprocal and I got this. Is this clear? Lubena, clear? Bakiyon clear?
Yes.
Yes, sir.
Achha, same thing over here. I've got CH3CO CO2 minus 1 and divided by this thing. So this expression, I can find the value of this expression from here. I mean, all I just need to do is I need to put the H plus 1 and take it to the other side. So I'm going to carry this. So I'm going to carry this H plus 1, take it to the other side, and I get exactly the same expression. And so basically it's this expression getting multiplied by this expression. So I mean, your value becomes K2 divided by the H plus 1 concentration, multiply that by H plus 1 concentration divided by K1. And your H plus 1 concentrations, they get cancelled out, and it's basically K2 divided by K1. So you just divide the two values. I mean, this value divided by this value. Can anyone tell me what the answer is? Yeah, when the calculators, take out your calculators, tell me what the value is.
Sir, is 2.9 to 10 to the power minus 7.
नहीं पॉजिटिव वैल्यू नहीं होनी चाहिए थी एक सेकेंड इट्स
0.04.
नहीं it's a bigger it's a smaller value divided by an even smaller value, so that should be a
I got 0.04.
it's going to be 4. I mean this is going to be 4.07. ये देख लो 4.07 into 10 to the power minus 3, and that's being divided by 1.78 times 10 to the power minus 4. ठीक है, maybe I'm wrong, but it should be a bigger value. It's मैं इस पे भी कर लेता हूँ. Just give me 1 second. Lubena, did you do this? Shafar, can you reconfirm this? It's
2.28 multiplied by 10 to the power minus 7.
नहीं अच्छा ये फिर सारे everyone start
Sir, I just got 22.8.
कितना?
Yeah, 22.
Yeah, sir, it's 22.8. My bad.
ठीक है 22.8. अच्छा just make sure जो भी सारे गलती कर रहे थे ना, tell your calculator put brackets around your when you're solving this. ठीक है, calculators ये answers सही नहीं निकालते. Make sure you use brackets when you're doing this. It's going to be 22.8. So you're getting a big value, right? What does that indicate? Equilibrium lies to the left, in the middle, or lies to the right? What? I mean, he's talking about this reaction. Is it favoring the products, favoring the reactants, or is it right in the middle?
It's favoring the product.
Okay, remember, whenever you get a bigger value for an equilibrium constant, that means you've got more products compared to reactants. So it's favoring the it's favoring your products. And you have to explain. So you just say that they, I mean, write this expression, tell them that the only way you get bigger values is it's a big value. I mean, that's probably the only explanation for that. So that means products are more compared to reactants. Now, the next one is, he's saying ethane dioic acid has two dissociation constants, K1 and K2, whose values are 1.23 and 4.19. So he's taken the negative log of K. Suggests equations to show two dissociations. Now, I told you previously that you have diprotic acids, are acids which have two acid groups. or that are capable of releasing two H+1 ions. Ethane dioic acid, this is also known as oxalic acid, it is capable of releasing two H+1 ions because it's got two carboxylic acid functional groups. So इनको dissociate करना है, and I told you that acids ionize or dissociate one by one. It's not that both H+1 are going to be lost together. The first thing that would happen is one of the H+1 would be lost. And once that is done, then you have this ion. Then it loses an H+1. And I also told you that the second dissociation is always a lot harder because when you're dissociating for the second time, the ion already has a negative charge, which means it would be attracting H+1 very strongly. It would be very hard for it to lose another of the H+1 ions. So there's more dissociation. So the first dissociation is always easy. The second one is kind of harder. Is this clear? Do you remember that?
Yes, sir.
Yeah.
As I state the mathematical relationship between pK and the acid dissociation constant, whenever you take P, that's basically the negative log of something. POH, pH, pK. So this is pK. And what does the negative log do? It inverts things. Like the smaller means the bigger value. I mean, like if pH is low, that means H+1 is high. So if pK is low, that means K is high. You can always remember that values kind of get inverted whenever you take the negative log because of the negative sign. I did explain that whenever you multiply something by something negative, the bigger value becomes the smaller value and the smaller value becomes the bigger value. So pK low means, I mean, this is not required, but pK low means larger K. That means more dissociation. I said our next one is you've got we can kind of ignore this. This is mostly organic, so leave that. Move to the next one. So the ionic product Kw for D2O has a value of 1.35 times 10 power minus. I mean, D2O, remember, is heavy water. D is basically deuterium. It's an isotope of hydrogen. So think of D2O as H2O. It's going to have the same chemical properties. The only difference is that the mass is going to be different. I said write the expression for D2O. We did write the expression for Kw. For Kw, it was that water ionizes and it produces two ions. One is H+1, the other one is OH-1. Now, if you've got D2O, it's going to ionize in exactly the same way. It's going to produce D+1 ions and it's going to produce OD-1 ions. So the ionic product of water is going to be D+1 concentration into OD-1 concentration, where D, remember, is an isotope of hydrogen. Okay, is this clear?
Sir, there will be no equilibrium sign in D2?
Sorry, this is exactly the same. It's
Okay.
I mean, they're both exactly the same. Only thing is that you have an isotope of hydrogen. And what's the normal value of Kw? Like if you have normal water, what is the value of Kw? Well, how many H+1 and how many OH ions do you have? Anyone क्या होती है? Ruba, any idea? Lubena? Like in normal water, what's the concentration of H+1 and OH ions under room conditions? ये तो पता होना चाहिए, सबसे basic चीज थी कि it was 1 times 10 power minus 7 mole per decimeter cube. Which is why your pH came out to be 7, because when you took the negative log of this, you got 7. And the ionic product of water, the value of Kw, I mean, for water, it's 1 times 10 power minus 14. Is this clear?
Yes.
But over here, obviously, you're using an isotope, a different water molecule, right? So it has a different value. It's 1.35 times 10 power minus 15, which indicates that it's even lower. That means its dissociation is even lesser compared to water. So you're being asked to calculate the pH of pure neutral D2O. So for pH, you would need H plus 1. We don't have H plus 1, we actually have D plus 1. Remember, D plus 1 and H plus 1 are the same thing. It's just an isotope of H. So these two ions are produced in exactly the same quantity. So that means if the concentration of this is X, the concentration of this other ion is also X. So it's going to be X into X, and it's equal to 1.35 times 10 power minus 15. To find X, you would have to take the under root. What do you get if you take the under root? And again, use brackets in your calculator.
3.6 multiplied by 10 to the power of negative 8.
So you're getting 3.6. Remember, if the original value has an accuracy of 3 significant figures, your answer should also have an accuracy of 3 significant figures. So is it 3.6 or something after that as well?
7.
Into 10 power what? Minus?
8.
So you're getting minus 8. So that's the concentration of D plus 1 ions, which is basically H plus 1. Is this clear?
Yes, sir.
और फिर इसका ना वो लोग नेगेटिव लॉग लो pH निकालने के लिए. So negative log of D plus 1, what would that be?
7.43.
So the pH is 7.43. So D2O is a different type of water molecule, and its ionization is slightly different compared to the normal H2O. So that's the answer to this one. Let's try and do this one. I mean, this is an acid. TK, if you can recognize this, it's an acid. It's basically HA dissociating to form H plus 1 and A minus 1 ion, right? So over here it's indium, I think. I don't know what ion is, but I think it's indium. So ion is it's H plus 1 with ion. Now, no, sorry, this is phenolphthalein. So they're saying that phenolphthalein has this formula. The Ka value for phenolphthalein is also given. So what's the expression for Ka? Ka would be H plus 1 concentration into ion minus 1 concentration, and the whole thing would be divided by. So the whole thing would be divided by HIN concentration. So that's your K expression. You know the value. It's 5 times 10 to the power minus 10. Then they have given you something. He's saying the pH is 8.8, right? That's also given. So from pH, you can figure out H plus 1. How do you figure out H plus 1? Take the anti-log, which is 10 power minus 8.8. Right, so H plus 1 concentration is 10 to the power minus 8.8. Is this clear as well?
Yes, sir.
Yes, sir.
So that's 10 power minus 8.8. So you know two things now. You know this, and you know the Ka value as well. The only thing is you have to figure out the ratio. You have to figure out this ratio over here. So all you have to do is you have to get the H plus 1 over here and divide this by 10 power minus 8.8. Is this clear? Clear है सारों को? Abdullah, is this clear? Ahmed?
Yes, sir.
Yes, sir.
क्या बना आंसर क्या है?
Zero 0.31.
ठीक है 0.3
0.32. 32 भी लिख सकते हैं. Because
नहीं,
it's 315, right?
so it's going to be
So you can
3.
make it 3, yeah, 32.
So it's going to be 32. So remember that it's going to be 0.32 and up to this value is accurate up to 2 significant figures. This is 2 significant figures. So your answer should not be in 3 significant. It cannot exceed that accuracy. ठीक है, so it's going to be 0.32. ठीक है, ये याद रखना कि make sure your answers don't exceed the accuracy that's given in the question. So then next one is, I just sorry, we didn't do one thing, which is solubility product, but we can ignore solubility product for now. Let's just keep, okay, this is a big topic. So this is also solubility product. Just a second, we'll just do the pH questions. Okay, solubility product is completely different. It's got nothing to do with this, but it's part of Equilibria. So we've got bromic acid, HOBr, it's a weak acid, so calculate the pH. So now if you have just a weak acid, what was the formula of finding the pH? It's like if you have HA ionizing to produce H plus 1 and A minus 1, right? The K expression was, if I derive the K expression again, it's going to be H plus 1 concentration into A minus 1 concentration divided by the acid concentration. And since H plus 1 and A minus 1 have exactly the same, these two have exactly the same concentration, so you could write this expression as H plus 1 squared divided by your acid concentration, right? So you have the value of K that's given, and you have to find pH. The acid concentration is also given, so it's hydrobromic acid. So it's going to be H plus 1 squared divided by the acid concentration, which is already given at 0.2. The K value that's already given, that's 2 into 10 to the power minus 9. So can somebody tell me what the pH is and tell me what H plus 1 is?
The pH is 4.7.
कहते हैं it's 4.7.
7.
ठीक है, and it should be accurate up to 2 significant figures. This is 2, this is 2. Answer should not be in 3. It cannot exceed 2. And then the next part is they're trying to make a buffer. So can you try and solve this one? I mean, we will be solving this in the next class as well, but they're trying to make a buffer now. Now, the first thing is a buffer is, you've got HOBr, right? Remember, you should be able to figure out that HOBr, it dissociates, produces H plus 1, and the other ion that is produced is OBr minus 1, right? Now, you've got HOBr. A buffer is formed when you have HOBr and its conjugate base as well, right? I mean, you have the same expression, except that the negative ion, I mean, this ion concentration, I mean, you use the same K expression, except that these two are no longer going to have the same concentration because this ion is added separately into the mixture. So now he's reacting HOBr with KOH. So there's going to be a acid-base reaction. You should know that an acid would react and the H in the acid, like imagine if this was HCl, it would become KCl, right? So over here it's HOBr, so it's going to become K plus 1 and OBr. A salt is going to be produced and a water molecule is going to be produced. Is this clear?
Yes, sir.
Yes.
So after that, what would happen is that you can figure out the moles. So the moles are 5 into 0.2 divided by 1000. You can figure out the moles of HOBr. पहले तो first thing is find out what's present at the end of the reaction. ठीक है, ये सारे ना आप बैठ के सॉल्व करो. आई एम सेंडिंग यू द स्क्रीनशॉट एज वेल. डू सेंड मी, क्योंकि अभी स्टार्ट में ना इट्स नॉट अ बफर. रिएक्शन के बाद इट वुड फॉर्म अ बफर. ठीक है, वी डिड डू क्वेश्चंस सिमिलर टू दिस, तो ट्राई एंड सॉल्व दिस. ठीक है, तो इसका मुझे आंसर भेज देना. चलिए, लेट्स कंटिन्यू टुमारो देन. ओके एवरीवन,
Okay, sir.
टेक केयर, अल्लाह हाफिज़.